This is a review of 3 of the most basic polynomial factoring techniques that you have already learned before and how to factorize polynomials where 2 or more of these techniques can be used. The first method is factoring the greatest common factors. For example, let's take the polynomial 4x cubed plus x squared y. Or let's make that 8x squared y. The greatest common factor of this polynomial will have the greatest common factor of the numerical coefficients and the greatest common factor of the literal coefficients, or the variable part of the expression. The greatest common factor of the numerical coefficients 4 and 8 is 4, so let's write that down here. The greatest common factor of x cubed and x squared is x squared. Now remember that we just take here the variable that has the smaller exponent. Since the first term does not have a y then is not part of the common factor, of the greatest common factor. So the greatest common factor of this polynomial is then 4x squared. Now what do we do with this greatest common factor? What do we do next? We divide each term of the given polynomial by the common factor, and since and the answer we place in this bracket. And since the polynomial given has 2 terms, then we would expect 2 terms to be placed inside this bracket. Now let's divide 4x cubed, the first term, by the common factor 4x squared. This is equal to, the 4 here will cancel out, and x cubed divided by x squared is just x, so we place that answer here. The second term, 8x squared y divided by 4x squared. Here, x squared will cancel out. 8y divided by 4 is 2y, and we place that answer here. Now, since we are dividing a positive number by a positive number, the answer is positive, so we will place a positive sign between these 2 terms. And that's it. It means that the factored form of 4x cubed plus 8x squared y is equal to 4x squared times x plus 2y. Let's take this next example, 2x squared plus 6x plus 10. Let's go ahead and start by determining or finding the greatest common factor. Let's start off with the coefficients, the numerical coefficients 2, 6, and 10. So the greatest common factor of 2, 6, and 10 is 2, so we write that down here. Then we look at the variable. We have x squared here, x, but this third term does not have an x with it. So it means that x is not a common factor. So the greatest common factor of this polynomial is just 2. So we are now ready to divide each term of this polynomial by this common factor, and we will place our answer inside this bracket. And because the original polynomial has 3 terms, we will expect 3 terms inside the bracket. Oh, no, actually, before that, let me change this to a minus. Let me change this to a minus just so we can see what happens when a term is negative. Okay, let's go ahead and divide the first term 2x squared divided by the greatest common factor 2. So the answer will just be x squared. The next term is 6x divided by 2, which is just 3x. And because we are dividing a negative number by a positive number, the answer is negative, so that's why we are going to put a minus sign in between these 2. The last term, 10 divided by 2, is just 5. And because we are dividing a positive by a positive, the answer is positive, so we place a plus sign, a positive sign, between those 2 last terms. The next factoring method is called factoring the difference of 2 squares. An example of the difference of two squares is x squared minus 16. And this is called the difference of two squares because x squared here is a perfect square and 16 is a perfect square, and difference means subtraction. And x squared is a perfect square because it is a power of 2. The exponent is 2. 16 is a perfect square because you could express it. So x squared is already a power of 2. 16 as a power of 2 is 4 squared, or 4 to the power of 2. And to factorize the difference of two squares, we learned before that we will have two binomials. Each binomial will contain the square root of each term. The square root of x squared is x. The square root of 4 is 2. I'm sorry. The square root of 4 squared is 4. So we will have x and 4 in each bracket. But in one bracket, the terms are separated by a plus. In the second, it's separated by a minus. So if we have, say, 4x squared minus 25, we could express 4 squared as a power of 2. It is 2 squared. X squared is already a power of 2, and 25 is 5 squared. So we now have the difference of two squares. The factors will be, just get the square root of each term. Square root of 2 squared is 2. X squared square root is x. Square root of 5 squared is 5. So I will also have 2x and 5 here. But these first two will be separated by a plus, the second one by a minus. The last factoring method that we are going to review is factoring quadratic trinomials of the form x squared plus bx plus c, where b and c are just numbers. An example of this kind of trinomial is x squared plus 7x plus 10. In this case, b is 7, c is 10. And we learned that the factors of this kind of trinomial is, the factors are two binomials. The first term of each binomial is just the square root of the first term. So the square root of x squared is x. We find the second term of each binomial by looking for two numbers, so that when you multiply these two numbers, the answer is 10. When we add these two numbers, the answer is the coefficient of the middle term, which is 7. In this case, this is easy. That would just be 5 and 2, positive 5 and positive 2. So this is positive 5 here and positive 2 here. Or positive 2 here and positive 5 here, it doesn't matter. So those are the factors of x squared plus 7x plus 10. Let's take another example, x squared plus 6x minus 7. So we will have two factors, two binomial factors. The first term of the binomial factor, we get the square root of x squared, which is x. Then we look for two numbers so that when we multiply those two numbers, the answer is the last term here, which is negative 7. And when we multiply them, when we add them, the answer is the coefficient of the middle term, 6. And for 7, there is just 7 times 1. And because the product is negative, one of them must be negative, and we will have to depend on the sign of the middle term. Since our middle term is positive, it means that the larger number 7 will be positive, and the smaller number is negative. And this is negative 1. So the factors will be x plus 7, x minus 1, or it doesn't matter what the order is. So these are the three factoring methods that we have just reviewed. Factoring greatest common factors, factoring the difference of two squares, and factoring trinomials of the form x squared plus bx plus c. Now, Let's factorize polynomials that require two of these three for it to be fully factored. Usually what we do when we are factoring a polynomial is we always check for the greatest common factor first. And then after that, we check if either of these two methods work. So let's try some examples. Let's look at 2x squared minus 32. So whenever you are factoring polynomials, the first thing that we always do is to check if this first method works. In other words, check if there is a common factor, or determine the greatest common factor if it is possible. So let's check. 2x squared minus 32. 2 and 32. There is a common factor. The greatest common factor is 2, so we take that out. So now let's divide 2x squared by 2. That will give you x squared. And 32 divided by 2 is 16. And because we are dividing a negative by a positive, the answer is negative. So we now have two factors, 2 and x squared minus 16. So we now check if either of these two methods will work on any of the two factors. So obviously for 2, we can't do anything about it anymore, but x squared minus 16 is actually a perfect square trinomial, so we could use this method to factorize it. And for 2, since we can't do anything about it anymore, so let's just copy it down, but x squared minus 16 will have two factors, x plus 4 and x minus 4. And x plus 4 and x minus 4, those are already, they cannot be factored out any further. So there you go. You have fully factored the polynomial 2x squared minus 32. Now, what if the polynomial was not x squared minus 32, sorry, 2x squared minus 32, but 2x squared minus 30? Let's see what happens. Again, the first thing that we do is we take out the common factor. So we have done it already in example number 1. So it's just going to be 2 times x squared minus, but in this case, 30 divided by 2 is 15. So we look at the factors 2 and x squared minus 15 and see if any of these two factoring methods will apply. Of course, x squared minus 15, however, is not the difference of two squares, so we cannot apply method 2. Also, it's not a trinomial, so we cannot apply this method. So as far as 2x squared minus 30 goes, 2 times x squared minus 15 is its factored form, and that's as far as you can go. Now, let's take 3x squared plus 12x plus 9. First step, let's take out the common factor. So the common factor that we are looking for, let's look at 3, 12, and 9. Greatest common factor there is 3, so we take it out. X squared, we have x here. There's no x in the third term, so x is not a common factor. So we now divide 3x squared by 3. The answer is x squared. 12x by 3 is 4x, and we will have a plus here. 9 by 3 is 9, also a plus. I'm sorry, this is 9 by 3 is 3, and a plus. The next step is to look at, so 3 here cannot be, we can't do anything about it anymore, but x squared plus 4x plus 3. Let's see if we could factorize it using the third method, factoring trinomials of the form x squared plus bx plus c. Let's look for two numbers multiplied and gives 3, added gives 4. This one actually works. We have 3 times 1 is 3, 3 plus 1 is 4. So we could break down, we could factorize x squared plus 4x plus 3 as x plus 3, x plus 1. And that is as far as we can go. So let's take one last example. Let's have 3x squared plus 12x. But instead of 9, what if it is 6? So same thing, 3 is common, so we take it out. We have x squared plus 4x plus 2. Now, let's look for two numbers that will equal to 2 when multiplied and equal to 4 when added. And there's no such two numbers. So this is the answer. The factors of 3x squared plus 12x plus 6 is just 3 times x squared plus 4x plus 2, and it cannot be factored out any further.